picks a good report of Google or of IEEE, and then they want to just present those results and that particular using the same code from somewhere as if it is their own work. Now, here we always refer students to the academic integrity policy of the university. And the penalties are, if you're caught, either you have to retake project, and in some cases you can even be dismissed from the university. So I encourage all of you to take this as seriously as possible, because as engineers we are supposed to be building solutions and not really trying to copy solutions that may not even work in a particular scenario. Now, what types of projects do we engage in? I've divided them in two types. Can you still hear me?
Yes, we are.
Thank you so much. Yeah, we have two types of projects, and I will probably highlight some of the advantages of one over the other. One is research-oriented project, and the other are development-oriented projects. Let me start with development. Development-oriented projects, we expect a student to have something, I could say, that is tangible out there. So if you're going to build a circuit or a prototype or a device, well, you should, at the end of the day, demonstrate that this is what I've done and this is how it works. And this is the science behind the whole system. If it is software and you're building, say, a huge application, we kind of we frown upon here in the Department of Electrical and Computer Engineering, people who just develop an app. We believe that if you're to develop an app, that is more of information technology. So people in the computer, in the information technology and information systems department in computing are the guys who are going to really be working on apps. So if you're just going to develop an app, we'll ask you to think about the engineering behind. So that is key in development. What is the engineering contribution to your app? Or could we have paid someone to just go and spend maybe 3 weeks and they develop the app? So we are kind of biased against people who just develop apps. An app can be probably just one objective of the entire project. Sometimes we do prototype modifications. Maybe in 2020, Dr. Almas had a student who developed a particular robotic system that moves from one side to another. Now, Dr. Almas wants this set of students in 2021 to add probably some form of control. Can it move, say, on one leg? Can it grip certain bits? Things like that. The other bit is research. In research, we look at aspects of design, but most of the work will end, say, with simulations. You're not going to have some hardware prototypes, so most of it will be soft. The other kind of research that we also have our students take on is comprehensive literature survey, analysis, and provide recommendations. Sometimes I could give you a simple topic. Maybe we wanted students to investigate the possibility of carrying out renewable energy planning for the East African region. So you might find that for such a topic, a student is not going to really sit down and build something, but they will need to really scour a lot of literature, try to understand it, analyze it, produce a survey paper out of it, and provide recommendations on the way forward. Now, the challenge with this kind of topic is that you need a lot of guidance from a supervisor. So we kind of don't take this on because you need a very good student to come up with some good work. Otherwise, people will be asking, what engineering are you doing? But then, people who are looking at, say, things to do with management, engineering management, things to do with policy, things to do with innovation and entrepreneurship can also clearly look into this. Other projects could be around data collection, modeling and analysis, where you collect data and then you develop models and provide analysis. Or it could be experimental work in a lab where you're testing several components or devices or instruments, and you develop a report. Other bits could be really mathematical. You're using really applied math. You're using your engineering maths to model a problem and maybe come up with closed form solutions. Now, these two different types of project ideas have advantages. One is the research bit is good if you want to publish, because with good supervision and if you invest some time in it, you could easily publish a conference paper or even a journal. For the lecturers, if some student does part A and they leave, then another student does part B, you could combine both parts and you write a paper. And also now in the COVID era, where maybe some engagements are via online, we are pushing a lot for the research component, where we are looking at the design and simulation bit, in that we rely on software and also mathematical modeling and the like, or using our labs to actually generate quality fourth year projects. Can you still hear me?
Yes, we are still hearing you.
Okay. Then we can't discard the hardware component in the mainly because this provides good visibility for the university. Remember that our policymakers are really people in parliament, people in local government. They are really keen on what they can see, what they can touch. They will say students at Kyambogo University have developed a motorbike that does this, or they've developed a UAV that does ABC. So both projects are important, but the challenge with data collection kind of projects or development is that in the COVID era, sometimes sourcing for equipment or the components may not be as easy as people think. So as you decide this, you need to carry out serious risk analysis and ask yourself, will I be able to get my components in time? Will I be able to make it work? That is really important. Now, where do we get our ideas? Here we encourage our students to propose their own project. But that has limitations and serious disadvantages to the student, because you could be allocated to a supervisor who is not very keen on that particular idea. So remember, this is a student-centered kind of module, and if the person you're working with is not very keen on your idea, it becomes a challenge. We also have industry-based ideas. We do collaborate with several people in industry, some through MOUs with these industries or factories, or through on a personal basis. I know someone who works somewhere and they think they need a solution from the university. So in such a case, it is important to control and manage the supervision. It is very important to control and manage the supervision, because industry people might be very keen in driving the project in a particular direction, which does not provide a lot of academic merit. So this is important. But also there are also external projects from, say, I could get a project from Dr. Excellence or Dr. Sendegea from Kyambogo, and they help me be field supervisors here, and then they guide the research. Now, what we are really pushing for are ideas from our own lecturers, mainly because they are very keen on seeing this project up to the end, seeing it through up to the end. And this could be part of their ongoing research or a continuation of a previous project. And these days we have so many engineering calls, ICT call, COVID calls, and a supervisor or a lecturer gets an idea and is like, look, I can develop this with my student. So it could be from that. This is our preferred option here, mainly because we've realized that when this kind of project is done, the success rates are usually high, and it usually also ends up in some form of publication or significant research output. Some of the trending topics that we have are, I'm going to give generic areas. We have students working on embedded systems and Internet of Things. Cybersecurity is also picking up, especially cybersecurity for industrial systems. You realize that a lot of our students are taking on artificial intelligence and machine learning applications, mainly in agriculture and in health. We have several aspects of 5G, and that also includes network function virtualization that I've included here. In energy and power, we have peer-to-peer energy trading and energy systems. It's becoming key, especially as we have a lot more, as we hope to add a lot more distributed generators on the system. And then power systems resilience and reliability. We have a challenge with our electricity reliability, and so we keep asking, how can we make our system more resilient? Now, these are some of the general areas. If you need specific topics, you need to work with your supervisors in these to craft something out of this. Okay? So some of the sample projects we have right now that are running, I've listed a few of them there, 1 through 7. I'll not go through them because, and you realize that most of them are within the general areas that I've highlighted. But some are purely research, others are research which is really around modeling and implementation later on. Others are around just design and construct and test. Now, we push for research because it helps a student go through all the different aspects, things to do with proper problem formulation, design and modeling, and then implementation in form of, say, maybe a simulation or actual performance metrics testing. For the hardware components, hardware bit, unless we believe that there is significant scope, we tend to ignore it because students tend to copy projects of Google or of other places. So I would like to end part 1 of that presentation there, and then I take you through our process. And please give me about 5 to 10 minutes to take you through the processes that we go through here at Makere. Okay. So this second bit will take us through how do we select projects, how do we review our projects, how do we do the examination, report writing, and then we give a tentative schedule. Okay, so project selection. At the beginning of the semester, or sometimes even before the semester when people are carrying out their internship at the end of their third year, we ask students to engage lecturers and develop these ideas. And then we'll also ask lecturers to provide ideas so that the department creates a list from which students can select these ideas. So at this stage, we are not developing a full proposal, but we are really developing a concept. So of recent, we developed an online platform where students should be able to upload their ideas, but then also be able to read about ideas that have been availed by the different lecturers. So it is at that stage that then the student, having identified a particular topic, they consult the lecturers and then develop a document of about 3 to 5 pages. You're basically putting your mind to paper. So someone reads through and then they guide you, and that's what we'll use as a team to then allocate projects, where students have actually already registered. We also after you've submitted your project as a student, it will go through a 2-stage process. The first stage is really done by the project's coordinator to check if another student has applied for the same thing, or if you have a very similar idea and someone probably is at an advanced stage compared to you, or if it is actually just copied or plagiarized from elsewhere. Then the second bit is when we ask lecturers who are experts in a particular area to look through the project and see if it is worthwhile, if the scope is sufficient, things like that. We usually provide a list of projects that have been done over the previous few years. So here we have projects that were done since 2013 all the way to 2020. So you'll have to look at what did these other people do, so that you don't do something that has already been done, but also as well to avoid cases of plagiarism. But you could actually extend on someone's work. I'm getting some background from someone, some feedback from someone, sorry. Now, once you've submitted, the project should be approved. Now, it is important that once it is approved, you will consult with your supervisors. Whoever you've been assigned, make sure you consult them. Because at the proposal stage, you will need to indicate that you've worked with these supervisors. Otherwise, it creates a problem for a panel to be judging your work when you were not guided. So, one key challenge we've observed is this. If you allocated 2 supervisors, say you allocated Dr. Almas and Madame Susan, you might find that both of these people have a different way of looking at the problem, or they have different research directions they want you to take. How do you deal with that? It's a tricky situation which you need to deal with as a student, but most importantly as a team. So our recommendation is make sure that the team of 3 people meet and agree on research direction. Otherwise, you as a student will be pulled in different directions, and hence you will not progress. But it is important you work with both supervisors. We know that in any case, one person will be leading the discussions, one person will be driving the research direction, but you need to also engage your co-supervisor. Now, how do we examine our projects here? We usually give 20% to the proposal and 80% to the final report or the final work. So this is then subdivided into two attributes. One is 60%, which comes from the actual implementation of the report, and that is given by just your supervisors. Both your supervisors will contribute to the 60%, while the panel will contribute 40%. Before, the panel had a contribution of, I think, just 20%, but we realized that either some people don't consult their supervisors or students report they were not supervised. Maybe supervisor A was busy or absent, and then you end up with really poor quality or substandard work. So we are of the view that we need to increase the share from the panel, because the panel are really independent people, about 4 people, who will look at your work, and they will give you marks in an objective manner. Now, the 60% and the 40% cuts across both midterm presentations when you're presenting your proposal at the end of semester 1, and then at the end of semester 2 when you're presenting your final work. It is advised, especially at the final report stage, that both supervisors clear you before you present. We actually give what we call attendance sheets. So whenever you meet your supervisor, we recommend usually once a week or once in 2 weeks. Once in 2 weeks should be the worst number of times you meet your supervisor. So whenever you meet them, it is good practice for them to sign, because if they sign, that means that they've actually looked at your progress. So you will not complain at the end of the day. So why do we have midterm presentations? Can you still hear me? I'm about to conclude. Hello?
Yes, we can hear you.
Okay. Yeah, midterm presentations give you an opportunity to get feedback from other people, because it's a shame where you spend 6 months doing something, and then you go to a panel and everyone is saying, someone is rubbishing your work. Trust me, it's not a good feeling. We've seen people cry because it's at that point you realize you're not even going to graduate. So we give a chance to students at that proposal stage to get an idea of whether the scope is sufficient. Have they written their specific objectives well? Are they on the right track? So this is really important, so that you also don't do a project that was probably done by students 2-3 years ago, but probably your supervisor is not aware that that project has already been done. So that's why we hold midterm presentations. The final presentations, we make sure that if you presented to panel A during midterms, you also present to the same panel. So it is important that by the time you present to them, the feedback that they gave you, you incorporated it in your work. Now, the beautiful thing about panels is you'll have people whose expertise really differ. Some people might be experts in that particular area you're investigating, and others might not be their area. But remember, as an engineer, you should be able to, people or your audience or your community should be able to appreciate your ideas. So that is really key. And then they will give you some marks. So usually we give presentations about 10 minutes, and then you're asked questions. Now, in the event that power goes off or there's no electricity, presentations will still go on. So we advise students to come with hard copies of their presentation so that they share with the panelists, so that if power went off while you're presenting, you're not you're not really disadvantaged. You can actually continue. Now, one key issue is presentation. We've seen many students have very good work. Their supervisors are raving about the quality of work that they've done, but then they're so nervous. They can't present or put forward their ideas or their solutions. This is really embarrassing because some people get low marks or some people even fail because people start to doubt, did you actually do the work just because you can't present? So before you go to a presentation, make sure that you can actually present. So how do you do that? You do that by presenting several times, practicing several times with your colleagues. So for my students, I usually organize what I call poster sessions, like 3-4 weeks before the final presentations, which is really 1 or 2 weeks maybe before exams. And that panel sessions is to, poster session, sorry, is to give a student a chance to stand beside their poster, share their idea, their solution to different people, and then be able to respond to those questions. Also, the other method we use, list a few of us here, is in addition to meeting you as a pair or individual working on a particular project, we also give students a chance to present maybe once a month to all the students that I supervise. That helps to take the nerves away because you quickly realize that you're not alone in not knowing what you are probably working on, or you learn from each other and you become a lot more confident as you present. This is key because at the end of the day, I've had to recommend people for jobs because of their projects. Someone asks me, who can actually use this software? Or do you have a student who is knowledgeable in this? And the students you worked with and you feel are confident are the students you are going to recommend. I've also had the opportunity to work with very brilliant students who have ended up coming up with work that we've published in international conferences. So I encourage you to take this really serious. Now here at Makere, we provide what we call a 4th year projects handbook, which will help students to look at several aspects of their work. One is we provide a template for the reports, both the proposal and for the final report, so that you don't have to reinvent the wheel, just fill in your bits. We provide presentation templates as well, but it is important that you keep writing progress reports. Send progress reports to your supervisors so that you don't struggle with writing the report from scratch at the end of the project. That's why some people actually end up copying things from the internet, because they feel they want to graduate after 4 years. You're really worn out. You feel like, I need to be making money, I need to be out of this place. And then people end up taking the easy way out of copying off the internet, off several reports, which creates serious problems. Now, as I conclude, we give a tentative schedule where we have set deadlines all the way from the start. It is upon the student to make sure that they meet these deadlines. The dates may change, but the changes may not be that significant. One key attribute of an engineer is the ability to keep deadlines. So you will not be excused for submitting a report late. So if someone can't meet deadlines, it becomes a tricky situation. Thank you so much for listening to me, and I hope this can make your final year project process a lot smoother and easier, and something that you can enjoy and talk about. I always joke that you're at a job interview and someone asks you, what can you do? The easiest thing to really talk about should be your final year project. You're like, well, at the end of my 4th year, I worked on a project that involved A, B, C, D, and E. And if you've done a good job, trust me, you'll be very passionate about it. And whoever is interviewing you will be like, well, this person learned something and they can use it. So thank you so much. Please learn that, yes, the prototype may not work. Yes, you may not have perfect results at the end of it all. But if you've indicated to your supervisors that you've been learning along the way, you've been progressing along the way, you should be able to graduate, because this is to train you to be a researcher, to be able to break a big problem into small problems, specific objectives, and provide solutions to these small problems, which when combined, you come up with a good engineering solution. Thank you so much. And over to you, Dr. Almas.
Okay, thank you very much. Thank you very much, Dr. Serugunda, for that good presentation. Actually, most of the things which you have talked about, we have been telling our students. And at least you have given them very good idea how projects should be prepared, and especially the areas you mentioned where students are supposed to do projects, and to be very careful when they are selecting research-based projects. So with that, we thank you very much for that good presentation, and we might invite you even next time to share with us your long-term experience whenever it is needed. Thank you very much. I don't know whether you are still with us, because we are still continuing with the workshop.
Thank you, Dr. Almas. I'll stay with you until 2 p.m. and probably excuse myself.
Hello, Doctor. Dr. Jonathan.
Yes, hello.
My conclusion?
Yes, please. Dr. Almas, I didn't get you very well.
Yes? I'm sorry, we are not hearing you.
Okay, what I'm saying is I'm going to stay with you up to about 2 p.m.
Okay.
And then maybe excuse myself.
It's okay, thank you very much. Do you mind sharing your presentation with Susan?
I've already sent it to her.
Okay, thank you very much.
Thank you.
Yeah, thank you. Okay. Members, now we are going to have the names of the coordinator from Kyambogo and from our department, Dr. Solomon. Dr. Solomon Serunjoji is going to give us a brief presentation about the requirement. Dr. Solomon, can you hear us?
Yes, I can hear. Can you hear me?
Yes. You are welcome, and thank you for joining. You joined a bit late, but we'd like to inform you that we started some time back, and we started with Dr. Jonathan Serugunda from Makerere. I think you have heard his presentation was so insightful. It has given a very good insight to our students, and I'm sure they have learned a lot from that kind of presentation, and I think they have learned what their friends are doing in Makerere. So because both of us, we are tertiary institutions, we should avoid reinventing the wheel and share our experience and learn from each other. So we thank Dr. Serugunda for that good presentation. So we are requesting you a bit behind schedule. We are requesting you to give a brief presentation as we requested you to prepare so that these students understand the requirement for the project proposal and how they should prepare their work. Thank you. The floor is yours, Doctor. Or the screen, I don't know whether it is a floor.
Can you see my screen?
Yes, yes, we can see it.
Okay, yeah, so obviously, thank you very much. I have been attending and listening to the doctor from Makerere, and I think that he has really given a very good summary, which is not different from our requirements at Kyambogo University. So obviously, I'm not going to go through every a single word of this document, but we recognized the challenges, and we developed this research dissertation manual that every student must acquaint themselves with at the beginning, during, as well as at the end of their presentation or their research. So we call it a dissertation manual that addresses, all manners of research, including diploma, degree, as well as master's programs. So it's the same journey. So basically, a student is expected to take this very seriously because, as Dr. Serugunda said, it is the life of the bloodline of the student in terms of their ability to negotiate in a job situation or in an academic setting. So a project is always very important. So we expect that you take a lot of time, if not most of your time, in the concluding years of your journey towards developing very strong research skills. And the reason that this comes at the tail end of your course as a student is that you're expected to integrate all the skills that you have amassed right from the time you stepped into the university until the time that you are now working on your project. And most of these skills happen to be fundamental in nature. Most of these rotate around mathematical skills and modeling, research and reading, journals and trying to synthesize literature, and then coming up with your own write-up, which has to be very original. So we expect that in the first part, you will come up with a proposal, that is in the first semester, and that proposal is usually a short document of around 10 pages. And I'll try to focus on that now. So we assume that you've got a supervisor, you have a supervisor, and you have co-supervisors. Together, they form a research supervisory committee. And that you'll be required to fill a form to confirm that indeed going forward, that is your supervisor. And then once a project is selected and approved by the supervisor, either it could be a project that has been suggested to you by the supervisor, or you have probably come up with it by yourself. In any case, you have to sign and put the title on that form. So once that has been done, you have a supervisory committee. Then you can go into the details of preparing your research proposal. And this requires that you meet your supervisor, preferably once every week, to follow up on the progress. And it is natural to get stuck, but the most important thing is to see your supervisor. And it is not an excuse to say that my supervisor is not an expert in this field. It is only good enough that the supervisor is knowledgeable enough to guide you through the problem, because it's not the case that every time you're going to design one project, you must always find 100% a supervisor that matches that particular thing. But a good supervisor will be able to tell whether indeed on the right track or not. So the most important thing in all this is originality, and I think Dr. Serugunda did stress the issue of originality and plagiarism. So there is a software called Turnitin. Turnitin helps at the end of your work, you'll be expected to submit.
Excuse me, Dr. Serunjoji. Dr. Serunjoji, briefly, can you put your video? Some students, they don't see you on the video.
My video is there. You cannot see me?
You see him.
But we can see you.
Who is not seeing me? One screen is on the video, the other one is for the audio.
The moment you put this video,
we are seeing you.
We are seeing.
Thank you.
Okay.
All right. I'll continue. So I don't know where I was, but I will continue the discussion by saying that yeah. So plagiarism is no. Why? Because the project work that you are submitting is also going to be submitted into the library, and therefore it is subject to being cited, not only by you or by your colleagues or within the university, but also abroad. So if you copy someone else's project, there is a potential liability of someone else suing you, the university, and probably the government that sponsored you or that allowed you to operate in this manner. And I'll tell you, it can be a very serious thing, especially if the project turns out to be very lucrative. There is a big business around litigation that surrounds plagiarism. So I would rather you do things in baby steps and produce your own original work rather than copying from somewhere else. Okay, so that is very, very important, and that is why we have the project divided in two phases: the proposal part and the implementation part. Okay, so I'm not going to go through the dissertation manual. This will send, and you have to read every single bit of it. But what I'm going to do, I'm going to just simply highlight, the elements of this manual. So you have a cover page, you have a title, you have an abstract, which is just about 350 pages, like in a journal paper, and this summarizes your work. Okay, then you have some dedications, and so on and so forth. I have an example here. I have two examples that I'm going to give you: an example of a proposal and an example of a project presentation manual, how it looks like. So let me start with So assuming that John Jacob has actually, successfully come to the end of his journey, and he has developed a project entitled CMOS Transceiver Circuits for High-Speed Communication. Okay, so this is going to be the format. This is just a template. You have an abstract, which is pretty much just one page, but it summarizes what's inside your work. Okay, and it is also derived from the aspects of your research. So this write-up basically is an original content, and you're also going to sign. There is a page that you'll be signing to really swear that indeed the work that you're presenting is your original work. So you have some acknowledgements there. Then what is really, really important is the motivation. What inspired you to do this work? What inspired you to think that you're going to solve this problem or that problem? Which is why defining the problem is very, very important. Because if there's no problem, there's no inspiration. And if there's no inspiration, it means you probably copied it from somewhere else. So what motivates you? It's it is the things you see. Is it the traffic jam that motivated you? Is it because you were involved in an accident? Is it because of this and that, So that's the motivation. Then the objective. The motivation could be quite broad, but the objective narrows it down. You know, you could argue that, all right, I'm going to, let's say that we are now in coronavirus time, and your objective is to design maybe an optical or electronic sensing device that could sense someone who has coronavirus without really having the physical thing. So you narrow that down to something very specific. In that project, probably you're only going to design the interface to the testing kit. You're not going to design everything, but the interface. That's why objectives are very, very important. Okay. Then you tell us how the thesis is organized by telling us which chapter has what. And then, yeah, you have a background. This is the most important part, the literature review. Basically, it shows the reviewer of your project just how much time you've taken to actually ensure that this project is not already done, or what improvements are you going to do. So you take us through the journey. When did it start? Did it start in 1970s? Okay, in the 1970s we had this disease, maybe Ebola, and how was it treated? And then we had another disease, maybe cholera, and how did the people manage it? And then we had another disease, maybe, and so on and so forth. And then finally, you come to the point where you insert the issues that are not yet addressed, okay? And that is where you end your literature review to the latest body of literature. And then once you've reached there, you have defined the problem. Now you start to actually insert the work, the methodology. What am I going to use to do this? Am I going to use numerical simulation techniques? Am I going to use Fourier transforms to maybe study a picture? You might be solving a problem to do with investigations, police investigations. And then you say, okay, my technique is going to be Fourier transforms. And then you do that, and so on and so forth. So I'll stop there and quickly go to the conclusion here. Or rather, let me go to the slides. So now you have presented your work, and you have submitted a dissertation, thesis or project to your supervisor, and your supervisor has endorsed, or he has signed off that indeed student X, Solomon, is ready to present. A student cannot present unless they have submitted a copy of their work to their supervisor and to their co-supervisors. So in this, you'll have an outline like this, which has an introduction, motivation, justification, background. You have the text, which is your actual work, and then the conclusion, and then the future work. So in the introduction, you have some soft launch into the hard work. So pictures speak louder than words. What I have seen is that most students put a lot of text, but they forget that you're presenting to a general audience and people are seeing your work for the first time. So show us a picture. What is the state of the art? Try to put your work in literature and put as little text as you can. And as you can see here, there are only 3 lines here. High demand for bandwidth. That is enough. And then explain the pictures, okay? The same thing is done on this slide. You demonstrate, okay, that we have different communication formats. You tell us that, okay, this is non-return to 0, and this is duobinary. And then you use a table to illustrate, the different things. And you use some kind of curves and so on and so forth. But you should not put a book text kind of information in a slide. It looks very, very poor quality, and it demonstrates that you're not really ready to amplify your information. And so you try to summarize and to simplify the slide. The slide is there to communicate not details, but simplicity, okay? So then you talk about the applications, where your work is actually finding applications. And then again, you try to, if you really must put a lot of text, try to put it in bullet points. Maximum 3, not more than that, okay? Maximum 3, and 1 or 2 lines at most. Trying to explain, okay, time domain analysis, the frequency domain analysis, or whatever you're going to explain. and then try to put a picture, maybe a block diagram. Try to illustrate how the signals are flowing at point A. Maybe this is the equation. At point B, this is the equation. At point C, this is the equation. Or if there is a signal flowing, try to use an arrow. Try to use an arrow to show that this is where the signal is going, and so on and so forth. And try to use that kind of format. If you have equations, try to explain the equations in full. You don't need a lot of text. So this is the block diagram in green, explain what it is. If this is the block diagram in red, try to explain what it is, and so on and so forth. These kind of tools illustrate your methodology. So in this case, the methodology is a mathematical modeling technique that is being used to analyze the signal flow through the diagram. So this is the methodology. So methodology actually means the tools that you're going to be using. Are they numerical simulation tools? Are they mathematical analytical tools? Or are you just going to use testing tools in the lab? Which tools are you going to use? Are you going to use an oscilloscope? And so on and so forth. So these are the kind of methods we look at. And then block diagrams again, speak louder than words, try to explain. You see, when I'm talking here, I am trying to illustrate that, okay, this is a max or a multiplexer, and then the signal goes into the flip-flop, and then the PL. You do not see a lot of text written here and written here and written everywhere, and then written here, and then this is not a newspaper, okay? I'm just trying to illustrate by way of block diagrams and showing you the most important part of the data, okay? And then you talk about the literature again. So this is literature, and what you do, you put a reference here. You see what is at the bottom of my slide here? It's a reference here. This reference, it shows the reader where this part of the work was taken from. You do not put a picture and you don't explain where it's coming from. That is not good. And then you try to use whatever techniques you have to explain your whatever. At the end of your work, try to compare your work with the existing work in literature. In this case, you say, this is my work. I used this technology. This is the output, the speed of my work, like this, like this, like this. And you compare it with others. So that when you really want to publish this work, it is a proper comparison with other people. Do you understand? And so on and so forth. So if you have another part of the presentation, again, you use block diagrams as such, but keep the texts very simple, and don't load the page with a lot of text. It is very, very poor way of presenting. And if you have equations, it's highly encouraged, because from year 1 to year 3, you have a lot of techniques. Some of them are numerical in nature, analytical in nature. Go through your coursework and see which techniques are appropriate to your work. Are they simulation-related techniques? Is it doing literature? Is it about questionnaires? Is it writing? Try to make sure that you bring out your techniques. So in this case, there is a control systems block diagram here that has feed forward, positive feedback here, and negative feedback here. And then there is an illustration of how the transfer functions are being used to solve that problem. So this kind of project is just nothing but an illustration of the work that you have, of the skills you have picked up from before. And you'll be surprised that it is much easier to publish a paper that is having fundamental skills than one that has a lot of copy-paste work from somewhere else. So just be mindful that it is better to be simple and original than complex, but having a lot of duplicated elements in your work. That is very, very important. So you go and look at the skills you've learned and try to put them here in your work. It will serve you a lot of due service. So these are just illustrations, and then in the end, tell us the original contributions of your work. What is the original contribution? Well, I designed nonlinearities. I designed a CMOS maybe amplifier. I analyzed frequency domain things, and also tell us what you were not able to do. Not able to do. I had challenges with the power. The software was not able to work. Do not be ashamed to say nothing worked. That is part of the problem, okay? You outlined at the beginning that you want to do X, Y, and Z, but nothing worked. And tell us what exactly did not work. That is part of the problem. So that the students that come after you will not start from scratch, but they will start by analyzing. Maybe you used a different technique. Maybe your software was not right. Maybe you did not have enough time. This is what research is all about. And don't forget to print your work and put it on the CD, okay? As you bring the hard copy of your thesis, also bring a CD along with your name and title, and probably a page. You know, like, you know, if you've seen those CDs with the wedding, with the wedding kind of print out, just put your name there, the title, and so on and so forth, together with the submission. All this will be going to the library. One copy will go to the library, and then one copy will be staying at the department. And these help us so that at any given time, when there is a problem 20 years down the road, we'll be able to go and at the department level, at the faculty level, and the university level to analyze where the problem. If they sue you for plagiarism, it's easier to see. You know, and I think Professor Serugunda was talking about your supervisor, meeting your supervisor regularly and taking notes. These will help you in the event that you're not even able to present on the last day. If you're sick, how will the professor justify that this student did some work if you do not have any scratch work or any rough work? By having that, or by sending your supervisor emails on a regular basis, it helps you to exonerate, or to exonerate yourself from these eventualities. So without further ado, I will stop there. But before I stop, I'll emphasize this word publications here. Publication is ultimately the journey. Is the only way that you will prove that you ever went through this school or college of higher education. So if you have publications here and here and here and there, it will be helpful. Now, you don't have to start publishing in year 3. You could start publishing in year 2 by doing a class project. It helps you to actually enhance your skills. So just be mindful that if you really want to go for master's or PhD at a later stage, the language they understand is not CGPA. So CGPA is only as good as getting you a job, okay? But once you apply for a master's degree program or a PhD program, grades are only part of the story. Ultimately, the most important thing is your research ability skills. If all you have was an A grade, but you don't have anything to show for it, then the committee will have a very, very hard time in trying to actually appreciate your school, because the problem is, internationally speaking, different universities are graded differently. Okay, the universities in the United States, in South Africa, in Uganda, in Kenya, they have different standards, right? And what is counting as A grade in Kyambogo University might be, a B grade somewhere else. And what counts as a B grade in for example, MIT might be an A grade in Kyambogo University or another university. So the only thing that is going to leverage, or that is going to level the playing ground, is your research skills, because you publish in the same journals like other people publish, and that is very, very important. So try to be mindful that research or a project is more important than grades. And don't forget, that is why this is allocated a weight of 5, right? Am I right? That the weight of the project is 5, and it's the only course unit that has this much weight, precisely because It can also help you to pull up your socks in the areas that you have not, done well. So treat this as the most important part of your academic journey. So without further ado, I would like to stop there, and I think I took quite some time to try and illustrate the key points of a good research topic, and also to emphasize that if you have spent 6 months doing a lot of work and your report is sent through the plagiarism check software, and we have a percentage there, the percentage must not be more than 10%. If your work has more than 10% of the work plagiarized, it will be rejected. You're not, it's an automatic thing. Now we're in, in the digital age, it will be rejected. And that is very, very important. So try to be as original as you possibly can. Thank you very much. So that is the first part of my presentation. If you have any questions or any illustrations, over to you, Dr. Almas. Thank you.
Thank you, Dr. Serunjoji, for that presentation. And I think students have learned from your presentation. And will you be able to share that document about how projects are prepared in Kyambogo?
Yes. Actually, this document is already available on Kelms. Kelms is the system from ICT that is used for course management. So it's already there. But after this session, I will also share it with the students through Madame Susan and all the other things that I have shown you here.
Secondly, you have mentioned, given an example how they prepare their presentation, but it will be very necessary also to prepare some sample projects you think which can be done by the students in your field, in the field of telecommunication. From which some you will supervise and others maybe you shall get another supervisor.
No, that's very important. So we can have a session of around 10 minutes just talking about the kind of projects. Just in general, I can give a quick outline and areas of interest. Yeah, that is something that we can do. I can illustrate that after this.
Okay, you will illustrate it, I think, after.
Yes.
Dr. Solomon, can you stop sharing? I want to start. I want to go. Wait. This one. I think I'm supposed to share this one. Yeah. No, present now. This one. Yes. Huh? He's sharing with others. What is it? Sharing. Okay. Oh, Jesus. Can you hear me? Okay, okay, I am the one who has been introducing. I think everybody knows me, those who are on the screen. Those people who are not in this room, are you? Can you hear my voice? Let one person say
yes, doctor, we can hear you.
Okay, now we are.
Yes, we can hear you.
I'm going to discuss issues related to concepts of power system, concepts in power system and sustainable energy issues. What kind of projects we can think about in this area? At first, when I was requested to prepare this, I didn't know that I'll be allocated very little time. I put there a lot of slides. I'll try my level best to go through the slides very quickly, which are not so relevant. I might skip them. And when we look at this presentation, we had a conference sometime back here, which was prepared by IEEE. Most of the slides, I used them. When I was requested to prepare a presentation on this, I remembered that I presented this kind of work in IEEE, whereby I was trying to give students an insight about projects in sustainable energy. I've added there a few elements in power systems. Quickly, that is my presentation. I'll give a quick introduction. Because my main task was to talk about sustainable energy, I'll say what is it. Giving this definition, I assume that students will be able to think about which projects can come out from this. And I want to base on the international concept, which was developed by UN in Sustainable Development Goals. What are those components in the sustainable energy capacity building? Because here we are trying to build the capacity, and then examples of projects. I start this by quoting those two important gentlemen in the world, how they looked at energy. For example, the former UN Secretary, is it still the current Secretary General? Ban Ki-moon. He looked at energy as a golden thread that connects economic growth. For him, he looked at energy by connecting it to economic growth, social equity, and environmental issues. And then another president of World Bank, he looked at energy because he's in money. He talked about poverty. Energy can help in ending poverty and ensuring sustainability. So whenever you talk about energy, the word sustainable does not miss, and economic development does not miss, and the environment. The great challenges when it comes to energy, I managed to look at 3 challenges. The first one, it is needed to end poverty, as already mentioned by those 2 great men, by ensuring universal access to modern form of energy, usually electricity. The second challenge, we need to strengthen our economy for prosperity and to ensure that we have equitable and satisfies growing energy demand. The third one, we need slow warming, global warming. Using conventional resources, they lead to that problem of global warming. In essence, we need to turn on lights and down the global. The most common form of energy we need is electricity. But when we look at electricity from our history, the main source of electricity, everybody knows that initially we used to get it from lightning. But for us now, when Faraday did his great work, we can get it through electromagnetic induction. But the technology is needed, ranging from renewable energy resources and conventional resources, nuclear, fossil fuels, coal. We are lucky, the last one in Uganda, we don't have much about it. We are basing more on renewable. But the world international community is worried about bullet number 2 when it comes to the environment. To have an idea, electricity access, very poor in Africa, we are still behind. By the year 2016, we had reached almost 30% of electricity coverage. Look at, for example, Middle East. Since 1995, they have been almost close to 90 electricity coverage in those countries. And when it comes to Southern Asia, it varies slightly low. But when it comes to Latin America, why am I giving you this background? To motivate you and think, do we need projects in energy? Looking at electricity coverage in Uganda by 2016 compared to other countries, it was 66%. Rwanda 35, Tanzania 33, Uganda 22 by 2016. 2016. I don't have the figure currently. I have to do research and establish what is the actual figure. Burundi, 9.3. We need energy. Access to electricity, comparing Uganda and Rwanda. Uganda, by and then really the world is in a problem. That is how the world looks like during the day. Interestingly, the sun, when you look at it, it is in Africa during the day. And it is too embarrassing at night, the Africa is dark. During the day, we have good sunshine. But at night, we are in problems. We need energy. We should think about solutions to our energy needs in Africa. When I talk about Africa, I mean in this case Uganda. There are a lot of technologies. This is one of the very interesting technology implemented in California, the concentrated solar power. You see all of this side is covered with mirrors, radiating solar radiation to a single tower, whereby water is boiled there and they run a thermal power plant. Mirrors covering to close 2 square kilometers. The sun in California, what in Uganda? Please let us give. You never give us who are struggling. The man is about diamond, he has given up. Maybe you are about to arrive where diamond is. Let us, what the academician, think more for Africa. Sustainable network about the economy, environment, and society. You separate if you want the economy, the society, and means engineers, they think for the society. To me, I call it stupid. Don't think for the society. Ask the society to tell you what they need, and don't tell them you are engineering. When it was introduced, I go beyond understanding engineering. I prefer social engineering than now electrical engineering. I mean, the physical engineering you think about. The society has more problems than the solutions engineers have. Engineers, we are created to think. I'm sorry to tell you that we are created. We didn't come to the world by chance. We are created to be there. I'll not go through United Nations Sustainable Development Goals. If you want, you can get this one from the internet. But what I want you to understand is that Sustainable Development Goals, they are talking about that word sustainability. The most important goal I want to talk about here is the goal number 7. We need affordable and clean energy services, which must be. Why do we think about this? Please, why do we think about this, about sustainable energy and capacity building? Whereas energy use is historical. Please, current solutions, all the solutions might not be used to solve current problems. Let us see the way we used to think. I remember I was telling students last time that for us, we used to have phones for rotating like this. Who has ever seen those phones? The current solution, the phones, is through sliding. Please, current problems need different solutions. That's the definition of sustainability. Supply and use. Sustainable energy is the supply and use of energy without compromising the energy demands for our coming children. Man is too selfish. We are trying to look at our current solutions and solve them. We don't mind about the future. Therefore, when we talk about sustainable energy, we mind about the future. With this, we should think, but don't work too hard. Work intelligently. Don't work too much. Work intelligently like the second man. If the animal refuses to move, use that tactic. Let us change the strategy to solve our reality. Therefore, the 7th Sustainable Development Goal is talking about that. Those are the 3 objectives. And you'll see that in my project ideas, they are focusing more on that. These days, when you talk about energy, we want to satisfy United Nations needs. 3 objectives: ensuring universal access. What are the solutions to ensure that everybody? I've seen the problem in Africa. People don't have access to modern energy. What solution do you have to help our colleagues in the areas which are not electrified? Doubling global warming rate. How can you reduce global warming? Reduce the excess use of diesel generators. Doubling share of renewable energy. The most important sustainable energy resources are renewable energy resources. Don't give up. Sorry, I bring in funny pictures in my presentation to motivate you and so that you be patient. Never give up. You never know. What doesn't kill you, it will make you survive. As I mentioned, those are the main areas: sustainable, that is the current solution, and nexus. The goal is sustainable energy for all. The solution that looks at 3 objectives, which I have already mentioned, and it will be very interesting what we need these days. Try to link, you know, I tell my students, there are 3 problems of the world. The main 3 problems of the world, 95% of the wars in the world are coming from these 3: land, energy, and water. If you can link your research to those 3, maybe the world will be peaceful. Sit down and think where wars are. If you look analytically, most of them, they originate from that. Why America attacking the Arab countries? Energy, oil. Why Israel are fighting the Palestinians? Why? Land. Water in deserts, they are fighting. You remember, you have been fighting with this, not fighting physically, but with the words with Egypt. Water, which we try to tamper with the River Nile. So when you link all of those, and these days, gender, women, try to come up with things helping women. Ladies, I'm challenging you. Always, whenever a female student approaches me, I tell them, think about a project in sustainability. Economy is very important. Complex, the resources are too complicated. Conventional and non-conventional. But where can we do? What can we do and where can we go? Never give up. We have solutions. Right? Don't give up. This thing cannot be solved. It has to fight up to the last minute. There are a number of sustainable hubs when it comes to sustainable energy for all. For example, improved exploitation of conventional resources. Can think about that energy area, that project, that area. Renewable energy development. In Uganda, we have abundance of renewable energy. Have we exploited it? Energy conservation. For example, taken in Africa, I'm going to use an example of DRC. DRC in the world has the highest hydropower potential. Actually, if Africans will stop fighting and we think together, the hydropower potential in the Democratic Republic of Congo, if it is well exploited, is enough to satisfy the energy needs of Africa. But we are disorganized, we don't think. Energy conservation and efficiency, it is an area we should think about. Energy, we utilize it in an efficient manner. Bottom-up energy access. How many people are accessing energy? Capacity building, academic institution, that's what we are doing now. Knowledge hub, governments, and development partners. Those are components, for example, sustainable energy. We can look at a complex network. We have ocean energy, conventional resources, and a number of different resources. Those are the components: renewable energy and sustainable energy. I repeat that sustainable energy issues are complicated. But we have to think, do we have, for example, all of these resources in Uganda? For example, in Uganda, we have a very big challenge of wind, but sun is in abundance, biomass, and water, hydro. But geothermal, very site-specific. not yet exploited. The only country in Africa which has exploited geothermal resources is Kenya. Yet there are so many countries with this resource. Energy and environment, we should think about energy and environment starting from the resource to generation process to delivery and consumption. You cannot avoid all of those stages and eliminate them from the society. That's why whenever I talk about energy and environment, we are looking at resources up to the generation. Energy policy. Dr. Jonathan was telling that at undergraduate level, this kind of research might be a bit challenging to you. But when it comes to higher level research, this is one of the parts which needs serious attention. Some of our energy resources and energy needs are not solved because of poor policies and poor governance. Educating the public is very important. There is energy and the public. How do we educate the public? Educating someone is like planting a tree. Energy and the economy. We need energy for economic development. Micro and macroeconomic issues. We can think about energy and related to economics. Improved energy management. I put that picture there to tell you that people, in fact, always I quarrel with my children at home. They leave the TV on and they sleep. Please, energy management and energy efficiency, utilization, a lot of interest in work there. Principles, different areas, principles involved in energy conservation. You have, for example, when it comes to energy conservation, we can talk about optimum control, optimize capacity, optimize load, use efficient processes, reduce losses, energy containment or suppression, examine energy conservation opportunities and energy storage. Capacity building is a very important area. Awareness among the public, very, very important. Need to identify high impact research opportunities, examples. For example, increasing rural electrification through use of renewable energy mini grids, sustainable biomass, energy saving cooking stoves, universal adaptation of cooking, water, energy, and food mixers. There is a project which I'm working on with one consultant. We are trying to look at the most optimum technologies to be used in water pumping in Uganda. A lot of opportunities in water pumping and renewables. I was talking to this, let's call them 7 towns water projects. They are now called, I think I forgot the terminology. They said that, in fact, they are witnessing that these days pumping water using solar is the cheapest. And that's why now our people remote from the solar, from the main grid, they buy water cheaper than we are buying here. They have already proved that, but there are a lot of opportunities to find out that. Number 7, for example, Makerere did a lot of that. You hear the Kia project vehicle. It originated from Makerere technology. So electric vehicle and fuel efficient is very important. And industrial energy use. Please, I keep on telling you, don't give up. Don't think that I'm giving you so many problems we have, we can't solve them. Work hard. The ongoing research, for example, I'm working on with, which is concluding very soon. We are concluding it in October this year. We have been working on a mini grid in Uganda with those universities, and the lead universities, South Africa, University of Southampton in UK. We looked at this concept in Uganda. And this project is a working project in Kyambogo district. Our main work here, my work and my research, have been 2 people working on this in case of Kyambogo. We have been seeing how can we integrate 2 isolated mini grid, what they call clustering. And very soon we are finishing our model. How do we cluster mini grids? But we are still looking at harmonic distortion, stability of mini grids. What is the problem with intermittent radiation? We looked at harmonics mainly and voltage regulation. But we have seen a lot of research opportunities needed here. We have seen one big problem that we need to investigate on, to make an investigation about energy storage. It is a very big problem with solar PV-based mini-grids. Therefore, after that long presentation, I thought, what could be very good project examples? These are some of the proposals I have in titles which I have in mind. For example, you can think about a plausible approach to assess solar PV water pumping, compare feasibility, hybrid power, solar PV, and generator set. It is part of the research which is coming from my project I've been doing. We looked at an isolated PV mini grid, but we want someone to optimize in case to improve reliability. How do you optimize a hybrid system with generator set, especially when it comes to fuel consumption? Probabilistic production cost when it comes to solar PV wind energy. We need to do more research in Uganda about high wind energy. The technology in wind energy is improving daily. There are some technologies which are using slow power, which need low wind speed. In Uganda, historically, we've been thinking that we don't have enough wind, but we have wind for generating power, especially for small applications like battery charging. The technologies are already developed. Assessing solar wind, like that. More about solar and hydro wind. Energy management when it comes to efficiency in building environment. This kind of research is a cross-cutting research, whereby a student doing it here in electrical engineering can do it with a student from civil engineering and architecture department. We are looking at energy use in buildings, development of energy demand side management tools. That is, we need it seriously in Africa, especially when it comes to institutions. For example, you can use Kyambogo as a case study. Energy and demand metering, collaborating wireless sensor nodes for energy monitoring through that wireless sensor network. These days, energy can be monitored wireless. We want to link that. Control and optimization of energy consumption in built environment. Number 11, 12, and 13, I was going through my presentation this morning. I received 2 mails from a friend. He showed me 2 projects going on in Kenya. From that, I thought about other projects. For example, number 11, in Kenya, they have a project, I think it is funded by World Bank. They are looking at pollution, electronic pollution from solar PV systems. That's why I thought about number 11. There is cost-benefit analysis. I've been doing a hybrid system, but no one has done a cost-benefit analysis. How can you look at the mixture of the different resources from an economic point of view? Modeling and simulation of power flow. Power flow has been a challenge in our model we have been working on. We need people to think about power flow models for mini grids. In power systems, these are some of the projects I managed to identify. Maintenance schedule for utility substations. Utility companies, they have problems in maintenance. Some of the problems we have with our power cut loss, outages in Uganda are because of poor maintenance. Modeling and transmission line parameters, but targeting how they can be used in load flow analysis, how they can be used in stability studies, and how they can be used in fault analysis. Earthing issues. Earthing is a very big problem. Most of distribution transformers, most of substation transformers, they fail because of poor earthing. There is a need to do research on earthing, modeling and simulation of harmonics. Harmonics, especially when it comes to intermittent generations, is a very big problem. Assessing impact of large-scale deployment of renewable energies in weak grids, like most of the grids we have in Africa. And we want to see their resilience in the case of that intermittent, modeling and simulation of harmonics, dynamic modeling, maintenance plan, technical and economic. I'm not going to explain them. Number 9 is very important. A lot of grid-connected PV systems are coming up in Uganda. Most of the technical and economic assessment are based on consultants' findings. But no one has done after implementing them to do a detailed technical and economic analysis. The current operation is based on the consultant work. Stability modeling, and number 12, clustering. We did not complete that project, but we developed a lot. It's unfortunate my researcher is not here, but I'm going to request her. We come up with the proposals from clustering, number 12. In conclusion, I'm sorry I've been moving so fast. In conclusion, sustainable energy problems are not yet solved. Be convinced, the struggle continues. We should embrace policy actions and consider affordability, reliability, accessibility, environmentally friendly, and generally renewables, energy efficiency, and powering consumers. With that powering consumers, there is a project Dr. Serugunda mentioned. It is a research which actually I was discussing with him last week. He has 2 PhD students doing a similar PhD in Africa, in German. We are looking at peer-to-peer energy flow. We want to stop that, the world, which is what they are thinking about. They want to stop this centralized power supply. If you have a solar system at your home, you are my neighbor, how can you share the energy? Using the existing grid. That is P2P, peer-to-peer energy flow. That is consumer empowerment. It's a research which is virgin and needs support. We can think about it. Therefore, I conclude with these, to me, I call them interesting pictures. If we want to solve our problems, please, dialogue is important. Look at picture number 1. Both of them, they want to eat the grass. They tried number 2, it doesn't work. Number 3, everybody is sweating. I think that's where we are in Africa. We haven't reached number 4 to share our energy needs and exploit them. We need that. Let us finish this resource. And I've given you an example of DRC. African countries should think DRC is a very rich country which can help Africa. Collaboration is very important. You see those people how they are crossing the bridge. We can cross the bridge if we cooperate. Always cooperation serves the purpose. Let us strengthen our collaboration and motivation. That's why these days we encourage group, 2 or 3 people working on a single project. And that's why I told you that we can do projects with other departments. Access to energy. This is something which we started. I had a discussion group with so many colleagues of mine internationally. One time we attended a conference and we are chatting, and in that conference, they put down together communications we should give to UN. We said in that conference, and they told us that whenever you give a presentation on energy, talk about that credibility. Energy, we should advocate for our politicians to make sure that they look, the way we have a right to live, the way we have a right to eat, also energy should be a human right. Not so that I don't have electricity. Why? It is a human right. The government must be answerable. I'm not inciting you. It is a move by energy experts we are trying to do. Teamwork, success will depend on teamwork. Our success in solving our energy needs will depend how we can work together. Thank you very much. Asante, Swahili, Danke, those who know German, Arigato, Japanese, and Okuota Chinene, that is Ichiherero in Namibia. God bless you. Thank you very much. Thank you.
Thank you very much.
Maybe I stop sharing. Where is the mute? You get it.
Thank you, Dr. Amos. Hand over to Mr. Capero to share a few biomedical and mechatronics ideas, project ideas. Okay.
Good afternoon. Are we there? Okay. It's a pleasure being here this afternoon and share with you some experience from projects coming from biomedical engineering, from biomedical engineers who may wish to do their projects in those areas.
Please note that Q&A is coming in after Mr. Capero presenting. So make sure your questions are noted down.
And it will be just a few minutes, 10 to 13 minutes will be enough to take you through this. And I would wish you give chance for those who are interested in these areas to capture something. There are so many areas that can be ventured into in areas of biomedical engineering, including analytes in blood and other body fluids. You can investigate the levels of blood sugar and so many other analytes in blood and the body fluids if you have interest in them. One of the leading causes of death in the developed world and soon coming to Africa is the cardiovascular diseases. You can come up with interventions that can prevent death due to cases of high blood pressure. You can look at areas of respiratory disorders, cerebral disorders, and the automated drug deliveries, among others. You can do areas of assistive technologies or devices, like for those who are having hearing losses or disorders, motor disabilities, visual impairment. We believe that if somebody has lost his ability to hear, but can see, can we develop that sense that is used for vision, instead loss of the what? The hearing sense. We can look at areas of
Mr. Kafero, can you please unmute your mic? It's on mute.
Yeah.
So have you not hearing me?
Now they can hear you.
Hmm?
It's now okay.
Okay. So we can perhaps these cases like partial velocity estimation of blood flow to the carotid artery rather than the carotid artery. Is it possible to develop a model that can determine the normal flow of blood through the carotid artery to determine those who have a problem when the flow is not, when the flow has been interfered with? If we can determine from the volunteers, we can come up with an algorithm that can help us determine the flow of blood through the carotid artery. So this requires a student with the medical imaging analysis and should have experience in this software, MATLAB. So can we do sleep detection using in-air non-contact sensors? Where people of target, long drivers, when they drive for a long period of time, they can sleep, but can develop an alarm to wake them up by using a sensor within their ears. When they are sleeping, most of the accidents come because somebody has been sleeping. Maybe a long trailer driver is tired and has resorted to sleeping. Can we design an implant within the ear that can alert him? So this is another area one can try to detect somebody who is developing some kind of sleep, right? Then can we develop a speech test and a hearing assessment among those with hearing disabilities? When we diagnose hearing disabilities early in life, we can mitigate the problem. So can we develop a speech test for hearing assessment early when the child is developing? So that's an area one can venture into. Then can we look at the interval between the first and the second heart sound? I don't know whether you remember your heart anatomy. The heart, first and second heart sounds. These are the lab and dab. The first heart and second heart sound. The first sound is because of the closure of the atrioventricular valves. When the AV valves close, we hear the first heart sound. Then when the seminal valves close, we hear the second heart sound. Is it possible to, can we determine the interval between those two and will tell us the functioning of the heart? Can we determine the interval between the first heart sound and the second heart sound and use it to estimate the QT interval? I don't know if you remember the QT. The electrocardiogram begins with the Q and ends with what? With the T. Begins with the Q and ends with the T. Can we use the heart sounds? Because heart sounds, you can hear them. You can put on the chest and hear the what? The heart sounds. So you can use the stethoscope and hear the what? The heart sounds. If we hear the heart sounds, can we use that to determine the QT interval? Because if you know the QT interval, it can diagnose the heart diseases without really doing the surgery, but you can be able to do what? Diagnose the heart sound by estimating the QT interval. The Q is the first phase of the electrocardiogram and the T is the last phase of the electrocardiogram. So if we can determine the interval between the two using the heart sounds, which you can hear, the lab and what? And the dab. Then can we use electrical therapy in wound healing? Can we design as students of electronics, and can we determine, can we manage a wound? Can we manage a wound using electric therapy rather than using medications, etc.? So there is a project one can venture into. I've tried to give the brief introduction. Objective, it's a mathematical model you can use to determine the wound healing procedure using electrical therapy. It is, you are not going to treat the wound, but you are going to simulate a mathematical model. It requires the student to be knowing the mechanism of wound healing. Are we there? You must be knowing the mechanism. It is a very simple thing. Following rupture of the body, we release platelets, they release thromboplastins. The thromboplastins release clotting factors, which convert the soluble plasma protein fibrinogen into the insoluble what? Fibrin. So that cascade, can we simulate it in wound healing using a mathematical model? it requires somebody with the, so can we, there's this concern here, eye training of infants using eye tracking. Somebody may have this condition, is called cerebral palsy. It is a disorder that occurs in children. Somebody is born with the abnormalities that can prevent development because of too much abnormalities within the brain. It is called cerebral palsy. But you can diagnose it using the eye movement of the baby. Are we there? You can design a sensor that can determine the eye movement of the what? Of the baby for, during early in life. And when diagnosed early in life, you can mitigate the, so it is eye training of infants using an eye tracking device to avert these problems associated with cerebral palsy. There is a brief introduction about it. If you have interest, we can continue reading about it, but I'm just enlightening you about it. Can you think about it? There's the condition is called cerebral palsy, which is associated with a lot of abnormalities within the brain that will affect the development of the baby. So if you can diagnose it early in life, we can mitigate it. But you can use an eye tracking device to see that somebody has a condition or doesn't have the what? The condition. There's this analyte in urine, which we call creatine. Creatine it shows a disorder within the kidney, and is like is a risk of kidney stones. Somebody can develop what we call kidney stones, and these kidney stones can block the ureters, preventing the flow of blood to the urinary blood and before voiding it. So if there is too much creatine in urine, it is a risky factor to what? Development of kidney what? Stones. So can we identify low levels of creatine early in life? I mean early in the diagnosis of the condition, and such that we can sort out the issue. So you can use this analyte, which you are calling creatine. Creatine is a product that is produced in urine, and if it accumulates in the body, it is likely to cause what? Kidney stones. So we don't wait for some to develop what? Kidney stones, but we identify the presence of what? Creatine within urine. I told you can investigate metabolites within the body fluids, like blood, like urine. So can you go in and find out the levels of creatine? Somebody talks about a smart toilet. And this, wherever somebody urinates, it will give us the signal that your what? Your creatine levels are so high. Are you saying that? Your creatine levels are so what? Are so high, and you're at a risk of developing kidney what? Kidney stones later in life. And when the kidney stones develop, you are likely to develop a condition they call nephrosis. Nephrosis will eventually lead to damage of the kidneys, and you need a transplant. Are we there? To avoid all that cascade, can you identify the levels of creatine in urine and treat the patient early before it gets worse? I think you get it. This is another example one can try to. Can we estimate the age at death? This is can be used in forensic science. Somebody was killed a month ago, but somebody claims was killed 2 weeks ago. Can you estimate the age at death using these devices by scanning the bones? And so that's another. Finally, you are not going to reinvent a wheel. I think you know that one in research. We are not going to reinvent a what? A wheel. We just look at somebody's project and look at two things. Where was the methodological gap? Was there a gap in the method used? Altogether? Secondly, did he leave a knowledge gap that I've done this, but you can proceed to do A, B, C, D? The first person who came up with the wheel didn't use a sport rim, but today everybody wants to drive a car with a what? A sport rim. That's not the initial invent of the what? Of the wheel. Didn't think about a tubeless. You get the point, But now everybody uses a what? A tubeless. Didn't think about tires without, the tires with wires. I think those ones are faded away. That's all technology. But he came up with the wheel, which has been manipulated over the generations. You get my point, If somebody did creatine analysis elsewhere, can we try to do that? Looking at his methodological gap he left, or looking at the limitations in his study. You get my point, So it is very, very important that you look at somebody's project and what are you looking for? Was there a gap in the method? Altogether, if there is a gap in the method, can I fill this gap in the method? You have issues with the project in biomedical. you believe that everything has been done. Not really. Nothing. Otherwise, people will come 10 generations to come. Will they not do research? They will still do research because every paper you see, there are limitations, isn't it? And their recommendations. You begin from his limitations or from his what? Recommendations and proceed. If somebody did cerebral palsy in children's in China, can we do it here? With my point, and find out that if I use an eye movement sensor, can I find out these children will have an issue with brain disorders later? You get my argument? So basically, I gave you this, and I think I will share these slides with you. If you have interest in any of those, please, we shall continue to what? To discuss about them. I think I've used the time I told you to use, about 10 to 15 minutes. Thank you so much.
Thank you very much. Now, let's
Unmute. Yeah.
Mr. Kafero, can you stop presenting so I can share my screen? Can you stop presenting so that I can? You have a presentation? Mr. Kafero, can you stop present? Can you stop presenting?
We have another presentation.
Can you see my screen? Can you see my screen? Yes, please.
Yes, we can
please.
see. You can see your screen.
Dr. Solomon, you can go ahead.
I can go ahead? Okay, I can go ahead. Okay.
Dr. Solomon.
Yes, please. Can you hear me?
Yes, can you stand like 6 minutes, please?
Can you please, what did you say?
Can you use 5 minutes to complete this, because we are running out of time?
You want me to use 5 minutes?
5.
Okay, let me know when the time runs out. It's okay. Is it okay? Okay.
Yes.
Okay. So I'll just generally give you some ideas. One, we have the fingerprint authentication. So some of these projects are already in existence, but they need advancement, okay? So fingerprint authentication, basically, how does someone come up with the technology to make that fingerprint child rescue system, which means that is it possible for a child who has been abandoned or a person who has been incapacitated, is it possible to send something to rescue them rather than humans? Silent sound technology, for the people who are dumb, who cannot talk, is it possible to develop something that just by moving their lips, they're able to decipher information, or to move their wheelchair, or to command, switch a light to go on? Can you come up with something like that? Then I'll skip that one. Bionic eyes. If someone loses their eye, can you, come up with something to based on artificial intelligence, to come up with an artificial eye? Then you have telepresence. So wheelchair control for the eyeball movement. This is similar to the dumb. Just by looking at the wheelchair, can you direct it? If someone does not have limbs, especially hands, and they're on the street, can you just can you develop something which will guide their direction just by eye movement. Night vision technology. This will help in detecting theft and other things. Speech recognition. We have so many languages. Is it possible to transfer directly languages? For example, you give a speech in your local language, and right now I'm able to listen to that speech in either English or German or any other thing. Or if a tourist is walking on the streets of Kampala and he's speaking Chinese, is it possible to translate Chinese directly into your local language and you're able to help them? Earthquake prediction in the eastern part of Uganda, Budud and so on, we have earthquakes. Is it possible to develop a technology that will mimic earthquake prediction just like elephants do? Digital signal processing. This is in image processing. You're able to come up with something that will detect, content in a digital footprint, especially in archaeology where they're using this kind of thing. Then I'll skip this. So then we have Markov and hidden Markov DNA modeling, projects that are basically DNA synthesis. For example, right now you all look African, but essentially you have different variations in DNA. So is it possible to do a DNA mapping of yourself so that if you ever need transplant or something, then it's a matter of looking into the DNA library and precisely treating you based on your DNA footprint. Optical camouflage. Is it possible to come up with something that will hide a person, optically, so that there's an illusion of someone, but the optical vision in front of them, hides them. Game design. Can you come up with some games, especially children's games or any other game, very, very easy. Just something bouncing around or a football or whatever. Air traffic control system, especially for collision avoidance. Can you develop a system that can mimic air traffic control? This is one thing. Pole climbing robots. Now we have so many jobs from Umeme, people climbing poles. Can you come up with something that will climb a pole at Umeme or on a transmission line and install something? Advanced divert control, an advanced approach to divert traffic at busy signals. This is something that you've been working on for many years, but it's not something new. Automatic self-parking cars. You go to Garden City or any other mall, and you're not sure whether you can park this car. All you have to do is to jump out of the car and press a button, and the car will park itself. Can you do that? Heartbeat monitor. I think Brother Cafe talked about that. Eye gaze communication system. Can you detect just by the way someone looks that there is a thief in the community, or there is something going on there? FPGA-based control system. So I'll jump that. This also Brother Cafe talked about. Anti-inflammatory and anesthetic medications.
Dr. Serunjoji?
Yes, please.
Doctor?
Yes, please.
Hello, Doctor?
Yes, I can hear you.
Dr. Serunjoji?
You cannot hear me? I can hear you.
No, what we wanted to ask you, can try to prepare maybe those present, because time is running out here. We have one presentation and people have to go for other engagements. Can you send that? We shall share with the students and request them to contact you. Yeah.
Thank you. No
Thank
problem.
you very much.
Thank you, Dr. Solomon. Please, if you're interested in the topics that Dr. Solomon has shared, you can get in touch with me so that I share his email with you guys. Right now we have a few questions from the students, and we had a few representatives. I don't know if they're still around. Mbaz Sadi John, Wanika Gerard, and Manager Hamim. If you're not around, you can just go through a few questions that were shared here. Someone shared a question about the data of previous projects done, if it's available, so that you don't do the same projects again. We are currently working on a database that is going to track all those projects, so you'll be able to see which project is done or which is not yet done, but it's in the pipeline. We are going to do that. Then someone asked a question that why is it that lecturers hate microcontroller projects? And I would like Dr. Almas and probably the lecturers here to respond to that, because that was the burning question. Doctor? Yes.
May I talk there?
You can switch on.
Okay, for me briefly, I can say that we don't hate microcontroller projects. A number of reasons why we tell students, please, microcontroller, you have not, usually students, you don't apply engineering. You just explain result. You just explain how the system should do, not how the system does the work. You don't understand microcontrollers. There is no engineering whenever you are giving presentation. For example, a student might say that microcontroller-based water level monitoring in a tank. He will not explain the engineering behind water level. He cannot understand what is the sensor is using. So long as he has got a microcontroller, someone has designed everything for him, he doesn't know even the programming of it. It is because students, we are not hating them, but if you can present a project properly, using a microcontroller, showing how you are going to use engineering, and in your methodology, you don't focus more on microcontroller, but you focus on how to solve the problem. That project cannot be rejected. But
the students are also asking.
Yes. Also, another person wants to talk about it. You can come. Use this. Use this. You can talk.
I'm Bagaiga Richard from Electrical. The other problem about the microcontrollers, there is a difference. Someone says he's having a microcontroller-based project. Then they come with the Arduino board. The Arduino board, okay, it's a microcontroller, but it's like a computer. Arduino board was a project done by a student from Italy. It was basically supposed to teach our students robotics, people who don't know engineering. So they came up with a board that had components of microcontroller. But someone comes with a Arduino-based project, it's a bit childish. That really shows that you are an engineer who has completed 4 years. So people they misunderstand. They don't get microcontrollers. They rather to differentiate it between the microprocessor and the microcontroller. So basically, a person who is having Arduino-based projects, you're assembling something. You're not, let me say, you're not developing something, but you're just assembling something. But maybe if someone had like a project, for example, is coming up with a board, at least that's a project. But you see someone having like 3 components. That is an Arduino board, a sensor somewhere, and a motor. And they are saying that is a project. So that is sort of like childish, someone introducing a kid to engineering.
Okay, thank you very much.
What was another question that I want to
You can mute. Another question, is it possible for students to come up with simulations? Join again. Go to your email. Go to your email. Look for mine. Is it possible for students to do simulation-based projects without tangible equipment? He also made a comment that projects are so time and money consuming. Doctor, you can answer that.
the question. I don't know what it is. But I have been telling that one to students. Even Dr. Jonathan Seruguna talked about it. You can do simulation because simulation you are mimicking or you are imitating reality and trying to solve the problem using computer simulation. That 100% is accepted. But the challenge which I found with most of the students here, they hate simulation-based projects because they don't know computer programming, software to be used in the simulation. For example, the common simulation program we use these days is MATLAB. Most students, they don't know MATLAB, Java, they don't know how to use it. And you might tell them that you can learn it in a few weeks and even use it. They don't. But 100%. And when you look at most of the project ideas I shared with you, they are simulation-based projects.
Himbisiwe has asked, can I develop an engineering concept outside my course, electrical? He's doing electrical. Can he develop an engineering concept around outside electrical engineering? Yes, Dr. Solomon, can you comment about it?
Yeah, very much so. Sorry, let me. Yes, you can very much. I mean, we live in a world, the world we live in is a world of senses. It's not a world of electrical engineering. Electrical engineering is just a medium of trying to express ourselves in the world, in the universe. So problems are inherently, coming from all walks of life. The problems are not electrical in nature. The problems are civil in nature. They are biological in nature. What electrical does is to put a transducer in between the problem and the medium called electrical engineering. So virtually all problems are not related to electrical engineering unless you're going to design something that is particle physics or gravitational waves or something. But by and large, all the problems are inherently non-electrical engineering based. So when you see someone, in hospital, that is a biological system. When you see a bridge collapsing, that is not an electrical engineering related problem. However, electrical engineering gives you the tool to improve on the lifestyle or to enhance the well-being of the society in which that problem exists. You understand? So absolutely, yes. Thank you.
Okay, there are two questions that I found were interesting. One of them, the student asked, what can I do if I'm given a supervisor who is not cooperative or who is not interested in the research I'm doing? That is the main reason why we gave you the Google Excel sheet. Write your name, the title you want, scope, probably problem statement, and your supervisor that you wish to be allocated to. Now, if the supervisor is not comfortable with the project that you're doing, it's going to reject it. And then we shall assign you a supervisor who will work with. If you feel the supervisor is not, with evidence, is not cooperative or is not interested, then there is room for change. But the challenge is you get to know that the supervisor is not interested in your area one day to your presentation. Yeah? So you have to bring facts that actually supervisor was not cooperative and is not willing to help. Then the last question was about, there's someone who asked, what do I do if a supervisor sells my project without permission? Please bring evidence that actually it happened. That is why you bring your reports, handbooks, and you keep them in the library. I think one of the presenters mentioned that. If you feel that your project has been taken with timestamps that you're actually the first person who did that, then you come and we investigate and find out. Then how do training institutions ensure that government supports towards innovation? We have various innovation hubs that come up. Unfortunately, when which project is selected for support and sponsorship is determined at the presentation. If the lecturers feel your presentation is quite good, then you benefit from those grants. Otherwise, don't expect to get support when you produce work that was not accepted by the panelists. Then lastly, someone said, Dr. Almas, we've always been doing projects in Kyambogo, but they just go unrecognized. But once Makere makes Kira EV, all news runs there. Why and how can we try to publicize our good projects there?
I know you mentioned that because I mentioned that Kira vehicle issue. Just something which came in my mind when I was presenting and showing you vehicles and what. If I give you the history of the Kira vehicle, we can also be there if we get such a project. The Kira vehicle issue started with Rockefeller Foundation funded project in Makerere. The project they used to call Mark.com project. And it was heavily supported by supervised by Dr. Tikodri. But he involved so many students from all other departments. The reason why that project sold it was donor funded. And from that, the government got interest in it. I'm sure also we can do it. In Kyambogo also you have done a project which the government has shown interest. For example, this the online system which all universities are using in Uganda. It was designed here in Kyambogo. So we can do it, but if you students also show interest and become very serious, we can come up with a project which can sell Kyambogo and we get support from also the government.
Okay. We've come to the end of this workshop. Probably some advice as you're preparing to present your project. There are a few rules that you should follow. One, you have to be confident with the work that you're going to present, which means you need to rehearse. And one of the ways of rehearsing is you can create a forum from the students, and then you rehearse to them exactly what you're doing so that you're confident and you prevent unnecessary mistakes. Then secondly, is dress code. I think a few of you have experienced this. You start presenting and the presenter is already off. Why? Because you've come with probably putting on a vest and shorts, you're not going to get the same feedback as those students who are really dressed to show that they're actually taking this on. Then finally, accept criticism. Yeah? If the panelists say something about your project, please accept and work around it. This is not a wrestling ground that you're going to flex with the panelists. Otherwise, we've already come to the deadline of handing in your proposals. There is a Google Excel sheet moving around. If you don't know about it, you can come and I share your email to that group. Please, the idea that you have, you can put it in that Excel sheet. A lecturer is going to come and comment whether the project is good or advise how to advance it forward. That Excel sheet is also, if you filling in that Excel sheet means your name will appear on the final presentation date. Otherwise, there is no way you can keep track of the students, which group, and what you're going to do. So please make sure that you do that activity latest this week. And we wish you all the best. We hope that this year we shall have very good projects. Have a probably fruitful week ahead. The deadline should be pushed. No, the deadline can't be pushed because a week from now or two, you're going to start your exams. So remember that we need to give a gap between when you submit your project and you doing another one in case it's rejected. So thank you very much for attending, and I wish you all the best. Yeah. Excuse me, if you need ideas in power systems projects, please contact Mr. Nasaga Musa. Unfortunately, he wasn't able to present because of time, but he's willing to help you and guide you moving forward.